all this
chickens
stuff, and at the
next.
end they die, and just like, oh, this is
Nutritional
nice.
discussion.
At least they give
So,
you like those couple of hours.
gonna
of,
take
like,
a look
happiness,
at
like,
any
no, keep
questions
them.
that
They're
might
putting all
come
this
up
money in
from
them. They're
Pascal's
meat
triangle.
rabbits. They are meat rabbits.
All right, children, I hate to interrupt your nutritional discussions. By the way, rabbits, I believe, are the most efficient in terms of turning feed into food for you and me.
And they're meat rabbits, so like why you can't just have meat rabbits
I
as
don't think
pets.
I've ever had rabbit.
Hassenpfeffer is a rabbit dish. So we did Pascal's triangle. We talked about it a bunch yesterday. We're live, just so you know,
Okay.
Oh,
in case Haley looks. I don't know if
hi
Haley's
Haley and
gonna-
Isaac in a past life.
So,
Aw.
so we talked Pascal's triangle. We worked on some of. We didn't work on that yesterday. We goofed off yesterday pretty much. So we went to the
What are you
bakery.
talking
No,
Wait, he's all. I
But
don't know if you remember what question 12 was, but it's the thing we already talked about.
Yeah.
Some of them sarcastic.
12 is just talking about how the coefficients of polynomials relate to the Pascal's triangle.
yeah, coefficients of polynomials
We already
related
went
to
through
Pascal.
it, so it's like, do you wait? What is it?
It's
Yeah.
like how do the
verify
coefficients
your-
for the thing relate to Pascal's
Yeah,
triangle?
so what do you have? Pascal's triangle starts out with 1, right? And then it becomes
1, 1.
1, 1, and then it becomes 1, 2, 1, which is
1, 3, 3, 1.
yeah. So x plus y squared is 1x squared plus 2xy plus 1y squared. I don't know if does she need that? Do you think? Do you think you need that? Is Haley gonna work on this on her own? Do you think, or what?
She already
I
did.
think she already
She did it before she
Think
left.
she already worked on Pascal's?
Yeah, I already.
Oh, I don't know about Pascal's. I'm
What?
assuming she did.
She worked on Pascal's. I know she told me she did. What about binomial theorem?
Oh, not. I mean, that's just what we said in class yesterday.
I know that's what we said in class yesterday. So really, in order to get out of the binomial theorem, all you need is that stuff that we had on the board yesterday, which, if we just put I mean, that gets you through the lesson. So you have Pascal's, which is like this, right?
3.
Yeah? And then if this is just x plus y to the 0th power, we have one term which is equal to 1. And then if you have x plus y to the 1st power, you have 1x plus 1y. If you have x plus y squared, you have 1x squared plus 2xy plus 1y squared. If you have x plus y cubed, 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. And then you can finish the rest of that, and then you can go do your homework. That's basically, that's the binomial theorem.
Oh,
Yeah.
it's cool, and you see, never thought of it, like it has in the bottom corner of page 631, where like, it's the first X, like it highlights them in red, and it's like, oh.
Yeah, so you can see that, yeah, bottom page, was it 631, did you say?
Yeah.
Yeah, it highlights everything in red. So you can see where all this comes from in writing out polynomials. So, you know, they write the binomial theorem real formal. X plus y to the nth is equal to n choose 0. X to the nth y to the 0 plus n choose 1. X to the n minus 1 y to the 1st. But what we did up there is the pattern of how all that fits together. So when it says to find the power of y and the coefficient of x cubed,
Oh,
in the
wow, that's
term,
painful to look
x
at.
plus y to the 8th, you could write the whole polynomial out,
Yes.
or since it's y to the 8th, or x plus y to the 8th, that would be what choose what to get, you know, so let's go up here.
What was the question?
So we want to know what in x plus y to the 8th, what's the coefficient of x cubed?
Oh, that's just 8 choose 3.
Okay, so it's 8 choose 3. Yeah, and we can see that here. You know, let's say we're going to look at this second coefficient here. That's of the squared value, so that's gotta be 3, choose 2. Is that right?
Wait, why?
Well, you did 8, choose 3 here.
Mhm. Oh, okay, yeah, yeah.
Is that correct?
Mm-hmm.
So let's see here, 8, choose 2 is gonna be 3 over,
Wait. Why is it 8, why is it 3 choose 2 if it's 8 choose 3?
I'm doing this one up here.
Okay, you're just proving it,
Just,
or.
yeah, I'm using that as an example to see that it works.
Okay.
So then you've got 1 factorial, because you've got 3 minus 2. And then you would have divided by 2 factorial, right?
And then 2 factorial out of 3 factorial cancels out, so it's 3
That's
over
just
1.
a 3, isn't it?
Yeah.
So if we were to do this one here, to come up with that coefficient, that would be 4, choose,
1.
so this would be x to the 4th plus to the 3rd y plus. So that would be 4, choose 3.
Why is it 4 choose 3?
Because you are looking at the row 4.
Wouldn't it be
This is
cheap?
row
Would it
0,
be
1,
free-
2, 3, and 4.
It's choose 1 because x is n minus 1, and y, well, with binomial theorem, n is reflected in y.
Because the extreme is always going to be 1, and then that's n choose 0, and that's 1, and the next one's n choose 1.
Wait,
Because then it goes, so it's like 1, the coefficient 1 is n choose 0, coefficient 4 is n choose 1. So it'd be 4 choose 1.
yeah.
So this is n choose 0.
I guess technically you're right because
Is that right? No, that's
Yeah.
n
Well,
choose n.
No,
it's right because this is 0, 1, 2, 3. So yes, technically this is right, but it's right, I think, for the wrong reason. Because this is 0.
Because of the reflective side of the polynomial.
Right, so
kind
this
of
is
thing.
n choose 0, n choose 1, n choose 2, n choose 3, n choose 4. So this and this are the same, but this is to that. Even though it's the same answer, I just think that this is wrong. This is right, but for the wrong reason. Because this is 4 choose 1.
So this on here is the same way. So this should have been n.
No, that's
was
right.
No, I did 2.
Oh, you did
And
do.
it should have been,
Oh.
It should have been 1, but it's again, it's
so this is 0, 1, 2.
Mhm.
0, 1. So it could have been this.
Well, like,
Yes.
the things I was saying right here, that x value right there, x
Mhm.
n minus k.
Yes.
So 4 is n. If 1 is k, then
Yeah. So this is 0 first. So that would be 4, choose 3. That would be 2. That would be 4, choose 3.
yeah.
Okay. So yeah, 4, choose 1. To confirm that that comes up being a 4, that's going to be equal to 4 factorial over 4 minus 1, which is 3 factorial, times 1 factorial.
Yeah.
So 4 factorial divided by 3 factorial is 4. Okay,
Yay.
sweet. So this,
Cool.
this is 8, choose 3. Is that right?
Yeah.
Because x to the 8th, x to the 7th, x to the 6th, the 5th, the 4th, the 3rd, this is the 0, 1st, 2nd, 3rd, 4th, that's the 5th. This is the 5th across. But if you have x squared, and then you have x to the 1st, and then you have x to the 0th down here, 8 choose 3 is 0, 1, 2, 3. So are those two the same?
This is 28.
Yes, those two are the same. So these two are the same. So this really wouldn't be, technically wouldn't be 8 choose 3. 1, 2, 3, 4, 5, 6. It'd be 8 choose 6, which is 8 factorial divided by 6 factorial times the difference between the two, which is 2 factorial. So that's going to be 8 times 7 divided by 2, which is 28. It's going to be 28x cubed y to the 5th. That would be that complete term. But they ask for the coefficient, so the coefficient's 28. You guys are gonna be okay with it. She's even gonna be okay with this, even though she's just sitting out in the sun getting sunburned. Hopefully not.